Good morning and welcome to our second session on graph plotting. Now, today we're looking at plotting quadratics. We started the worksheet yesterday and I modelled how to do a couple of different ones. The one I'm going to do today isn't from the worksheet, so hopefully yesterday I think we did up from question 1 to 8 or 1 to 9. The only reason to slow down and start at this second bit is this ugly looking number in front of the x squared. The ugly looking number in front of the x squared means that some people get confused as to what do I do first. Do I take x, double it, then square it? Or do I take x, square it, and then double it? So it doesn't take much for people to get confused. So I was asked some questions yesterday about, I'm not sure what this plotting bit means from -3 to +3. Well, the -3 to +3 bit just means that I'm going to substitute in numbers from x from -3 to +3. You could substitute x as 5, 10, or 57, but it's not going to appear on the graph that we're going to draw. So the reason for slowing things down a little bit today is because you'll see in my table, the extended table, not the same little one that was on the worksheet, I've got an extra row that I've not shaded in. So the idea is because we've got 2x squared, BODMAS says I've got to do the squaring first and then double my answer, because that's what the O to the power over I indices means, and then multiplying. Multiplying is less important than powers. So in the first instance, what I'm going to do is I'm going to take my x values from 3 to -3, and I'm going to square each one. 3 squared is 9, 2 squared is 4, 1 squared is 1, all the way along to -3 times -3 is +9. Now, we're not actually going to use the x squared values in the sum, but what we are going to use, is here, if I can actually manage to scrape off all this wonderful work that I've done, is because I've now got x squared, I'm going to double the value here. Double 9 to get 18, double 4 to get 8, and so on to get 2x squared. And that will be the first term once I've substituted all my values in. I'm then going to do the -3x bit. When x is 3, I always start at the positive side. When x is 3, -3 times 3 is -9. When x is 2, -3 times 2 is -6. And I move that way, and I keep seeing that the numbers are going down in threes. The +4 is a simple bit at the end. I just add 4 to each of the columns. Now, each of the rows, sorry. So what I've done is I've highlighted that in pink because I'm not adding it. I only used it as a stepping stone to get to here. Now, I know some of you are going, I'm quite clever, I don't need all this, but trust me, I've been doing this for 20 years, and the idea of taking a number, doubling it, taking the same negative number, multiplying it by a negative number, adding 4 and getting the correct answer, I see so many mistakes over on this side. That's why slow down, chunk your work, don't make a mistake. Now, when it comes time to adding the values that we've got there, 18, take away 9 is 9, plus 4 is 13. 8, take away 6 is 2, plus 4 is 6. And I move all the way along to get my y values. So remember, we always start off with the positives. We look for a pattern. And yesterday, the two examples that we did, there was a nice pattern in the y values. You know, this goes from 3 down to -3, but yesterday we saw numbers that were going down and coming back up and were symmetrical, whereas here we don't. So why is that? Does that mean it's wrong? No. Let's have a look. We're going to plot all our points. We're going from -3 in the left to +3 in the right, and the y, the lowest value of y is 3, the highest value of y is 31. And so miraculously, here's one that I've prepared earlier. The idea is, remember, label your x-axis, put your scale on. Label your y-axis, going all the way up to 22, all the way up to 32. And I'll start with the positives, 3 along and 13 up, 2 along and 6 up, 1 along and 3 up, 0 along and 4 up, and I'll go all the way back up. Make sure, again, remember, all of last week we were dealing with straight lines, so the points should all have been in a straight line. Here, everything should look like a nice smooth curve. I know this one looks a little bit like a fish hook because it's not balanced to one side, but if I were to put my hand here, you've got that standard U shape, smooth U shape that we should see. Also, when you're finished, get used to the idea of labeling and sticking the label to say that this is the curve, because some of us, when we're doing straight lines, we're adding 2 or 3 different lines onto one graph. Okay, what I'm going to ask you to do is I'm going to ask you to stop the tape to model. Stop the tape, how old-fashioned. I'm going to ask you to stop the recording. Put this down with the table as to how we set it out and the graph. That's your modeling for today's lesson. So now, what I'm looking for is for you to go and have a go at questions 9 to 13. Write the equation, draw the tables, show me the graphs. I know the graphs are difficult for those of you working on plain paper or line paper, but let's see if you can try and have a go. There are some ways, if you've got a printer at home, that you can download line paper online. I might see if I can find a way and attach that to some of the documents. Okay, so have a go, ladies and gentlemen. 9 to 13 today, please. Okay, enjoy.